Welcome to the lecture series of Industrial Engineering with subject code KME 503. I am Dr. Suman Gothwal, working as an assistant professor in the Department of Mechanical Engineering at AJAY GARG Engineering College, Ghaziabad. So in today's lecture, we are going to start about the concept of CPM and PERT. CPM is our critical path method and PERT is basically the program evaluation and review technique. And we will also discuss one problem based on the CPM PERT. So these will be the outline of today's lecture. First we are going to discuss about the project network analysis, and after that we will discuss about the what is the network, how can we draw the network diagram. Then we will discuss the different terms that we use in the network diagram. And then we will discuss about the different techniques of the network planning. Then time estimate and frequency in PERT will be discussed. After that, we will see how we can do the calculations in PERT. Then we are going to discuss about the project crashing and the algorithm associated with it. And last, we are going to discuss the problem based on the CPM. So first we will discuss about the project network analysis. So first question that arises, what is the project? Okay, so we can say that the project is a interrelated set of activities, means our project consists of a number of activities and these activities have a definite starting and the ending points, and these results in a unique product or service. Okay, so this is the, we can say it is the collection of various activities. Okay, so network analysis is a system which plans the project both large and small by analyzing the project activities. So if we want to complete a project on time, then we have to do proper planning, and the proper planning will be based on the activities which are associated with a project. And network analysis is basically will plan the projects by analyzing the activities. Okay, so we can say what is the network diagram? Network diagram is constructed which represent the relationship between all the activities involved. So with the help of network diagram, we can find out how different activities are related to each other. Time, cost and other resources are allocated to different activities. When we say the activity, then it will have a definite starting and ending point and it will consume the resources and the time. So when we will draw a network diagram, then we will indicate the time and cost with the different activities. We will not show the cost on the network diagram, but we will use this cost in the calculation part. But in case of the time, we can show it in the network diagram. Now, what is network analysis? Okay, so basically the network analysis were developed from the Gantt chart. So in Gantt chart, the things were not much clear. We were saying it like in 2 months we will complete activity 1 and in the next 2 months we will complete the activity 2. Like this we were doing in the Gantt chart. We are showing basically the progress report in the Gantt chart. After the Gantt chart, it was modified into the bar chart and then it was modified into the milestone chart. For example, we can see a graph here which is the showing the relationship between the different activities and the time. Okay, so we can see here there are 4 activities are involved here, A, B, C and D. Okay, and from this chart we can find out when particular activity is starting and when particular activity is ending. So in this diagram we can see the activity and A and activity B are starting simultaneously, but activity C will start only when the activity B will complete, and when the activity C complete, then we can start the activity D. So, it is only indicating the start and ending point of different activities which are associated with a project. It is not showing how these activities are related to each other. So, if we want to indicate the relation between different activities, then we will use the network diagram. Clear? So, what is network? Network is basically a graphical diagram which is consisting of the certain configurations of arrows and nodes. So, in network diagram we will have two things. First one is the arrow and the second one is the node. For showing the logical sequence of various tasks to be performed to achieve the project objective. So, here one example of the network diagram is taken. First, second, third and fourth. There are 4 activities are involved. So, it consists of the nodes. Nodes is this one, and this arrow is showing the activity. Okay. So, if we say activity A, B, C and D, there are 4 activities are involved in this network diagram. So, with the help of arrow, we will indicate the activities, and with the help of this circle, we will show the nodes, or we can say it event also. Okay. And one more thing, which we have to remember, that activity will consume the time, but the events or the nodes will not consume any time. This will only show the start and ending of an activity. Now, there are different terms which we use in the network diagram. First one is the activity. So, what is activity? Activity are basically we can say it is the task which is consuming the time, okay, and other resources also. What is event? Event are also indicated in the network diagram, and these does not consume any resources or the time. Okay, these are only showing the starting and ending point of an activity, but the activity will use the time as well as resources. Now, what is the dummy activity? Dummy activity is basically used to show the interdependence between two activities or between the different activities. Okay, how they are dependent to each other. So, we can show it with the help of the dummy activity. Now, we come to the critical activities. So, critical activities are those activities which should be completed on the given time or date, okay, within the time frame. If we will delay it, then the complete project will get delayed. Okay. So, there is no scope for the delay option. Okay. We cannot delay these activities. These are critical one, but non-critical activities are those activities, if we delay these activities, then the complete project will not get delayed. Okay. There is a scope of delaying it 2 to 4 days, or that will depend on the type of the project. Now, one term that we are going to use in our problems related to CPM and the PERT is EST and EFT. EST is basically the earliest start time, means the earliest time at which we can start a activity, and the earliest finish time means the earliest time at which we can finish our activity. Okay. Then we will use the LST and LFT term also. LST is basically the latest start time, means latest time at which we can start the activity. After that, if we will start our activity, then the project will be delayed. This is the latest finish time, means the maximum time which is permissible to an activity to be completed. So, if we will take more than this time, then our activity or our project will get delayed. Then we use the flow float or slack. So in case of CPM, we will use the term float, and in case of the PERT, we will use this term slack. Okay, and this is basically the difference between the EST or LST or EFT or LFT. Okay. Now we come to the network planning technique. So there are basically two types of techniques which are widely used for the network planning. First one is the CPM, which is known as the critical path method, and the second one is the PERT, that is the program evaluation and review technique. Okay. Now what is CPM? CPM is basically activity oriented technique, and there will be a certain activity duration. There will be a particular activity duration for each activities which are involved in a project. Okay, and it is appropriate for the deterministic situations where we can determine the different values. So in those cases we will use the term CPM. It is there is certainly in activity, there is certainty in the activity duration, and it is used for the construction project and the business problems. Now we come to the PERT. PERT is basically event oriented technique. CPM was activity oriented technique, but the PERT is our event oriented technique, and there is a probabilistic situation. Okay, there will be a probability in the activity duration, or we can say there will be the uncertainty in the activity duration. We cannot find a particular value. So it will be appropriate for the probabilistic situation because therein is uncertainty in the activity duration. So it is widely applied for planning and scheduling research projects. Okay. Now we have taken one example, we have taken one network diagram to show the CPM network diagram. So we can see here there are different nodes. These are indicating the nodes. Okay, and these are showing the starting and ending of an activity. So we can see in this diagram there are 10 nodes, and these are basically, here we can show it, we can represent it by a symbol also. These arrows are showing the different activities, and this is the basically the time. Okay, means activity, if we say the activity that is between 1 and 2 is taking the time 10, that time can be in the days or hours. Okay, so in this way we can represent our network diagram. Now the time estimates in PERT, because we have already discussed in previous slide that there is uncertainty in the activity duration. Okay, so how we will calculate the time, or what are the time estimates in PERT? So there are three different types of time we are going to discuss here. First one is the pessimistic time, the second one is the optimistic time, and the third one is the most likely time. So pessimistic time basically represent the longest time the activity could take. Okay, if everything goes wrong, and it is denoted by TP. TP is pessimistic time. If everything goes wrong means if the material or the resources are not available when required, then in that case the activity can take the larger time. Okay. Now the second one is the optimistic time. Optimistic is basically the shortest possible time in which the activity can be finished. It will be the minimum time in which an activity will be finished if everything goes very well, means the resources or the material are available at the time when it is required, and it is denoted by TO. O is for optimistic. Then we have the most likely time. So most likely time is basically the normal time the activity would take, means it is the normal time, and it will be between the optimistic and pessimistic time. So this time will lie between these two limits. Okay, and most likely time estimate represent the highest frequency of occurrence, and this is denoted by TM. TM is most likely time. So these are the 3 time estimates that we are going to use in case of the PERT. Okay. Now we have the time estimate frequency. So what is the frequency of these time estimates? So here we can see that there is a graph which is between the possible durations and the probability of occurrence. What is the frequency or what is the probability of occurring a time estimate? So here we have taken the duration and here is the probability. So we can see here it is showing the optimistic time. Optimistic is basically the minimum time in which an activity can take. Okay. So this is the minimum time, shorter time duration, but it is the pessimistic time. So you can see here that duration is this much. So it is the largest time or longest time the activity can take. This is the pessimistic time, and its frequency of occurrence or its probability occurrence is very low. Okay, and we can see here the most likely time estimate is here. Okay, and its frequency of occurrence is very high. So this is shown here, most likely used in original CPM calculation. Okay. Now we come to the PERT network diagram, because there are 3 time estimates. So in this network diagram we can see there are 11 events here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. There are 11 events are there, and we can see there 3 time estimates are shown here. Okay, and how we will find out what type of time estimates are there? So first we will have the optimistic time, which is the minimum time, then we will have the most likely time, and in the last we will have the pessimistic time. Okay, so how we will solve these PERT problems? Okay, so in this case basically we will find one single value of this time, which is known as the expected time. We will use some formulas to calculate the expected time, and we will write down that expected time here, and the procedure of solving this network diagram will be exactly same as we will do in the case of CPM. So here is the calculation that we can use in the PERT. This is the expected time. The times are combined statically to develop the expected time TE. So TE will be TO. TO is your optimistic time plus 4 into TM. TM is most likely time plus TP. TP is pessimistic time divided by 6. So with the help of this formula we can find out one value of the time. Then we can find out the standard deviation also. Standard deviation of the time required to complete the project. So this is the standard deviation, means value of sigma we can find out as TP minus TO divided by 6. We can find out the variance also, and variance is basically sigma square. Okay, so these are the calculation we can use in the case of PERT technique. Now we come to the next term, that is the project crashing. So project crashing is basically a method for shortening the project duration by reducing the time of one or more critical activities to less than their normal time. Okay, so when there are some cases when we are required to complete the project in a shorter duration. Okay, so in that case what we will do, we will minimize or we will short the time duration of some activities, some critical activities than their normal time. So overall project duration will be minimized in that. So here what are we doing? We are doing the we are basically shortening the project duration, and this method of reducing the activity time of one or more activities is known as the project crashing. Crashing is basically achieved by devoting more resources. So if we want to complete one or more activity in less time, then we have to provide the extra resources. Okay, so it will be achieved by devoting more resources, thus the cost associated with the project is increased. So if we are using or we are utilizing more resources, then automatically the cost of our project will increase. So our objective in case of the project crashing will be basically to reduce the project duration and to while minimizing the cost of crashing. So we have to monitor this also, that we have to keep it at the minimum side. Now there is a cost slope that we calculate in case of the project crashing. So here we can see a graph that is between the cost and the time. So this slope we are getting here, and at this point it is showing the values of NT or NC, and it is the duration at which it is showing the CT or CC. So what is the NT? NT is basically the normal time of an activity, and this NC is the crashing cost. This is the crashing time, CT is the crashing time, and CC is the crashing cost. So how we will calculate the cost slope? We can use this formula to find out the cost slope, which is CC minus NC divided by NT minus CT. So with the help of this, we can find out the cost slope. Now the algorithm for the crashing process, for the project crashing process. So first step is basically we have to determine the normal critical path and identify the critical activity. So basically the procedure for the CPM and PERT will be same. In case of the PERT, we have to find out the expected time first, and after that the procedure for solving the critical path or the project duration will be same for both the techniques. So in case of the project crashing also, what we have to do, we have to find out the normal critical path or the identity, and we have to identify the critical activities also, and after that we will calculate the cost slope, or we can say the increment cost per unit time for different activities. So for this project crashing, what we have to do, we have to calculate this cost slope for different activities. We will rank the activities in ascending order as per their cost slope. So based on their cost slope, we will arrange different activities. Crashing activities of critical path as per lowest cost slope first. So which type of activity we have to select first? We will select the activity for which the cost slope is lowest one. Okay, then we will calculate the new direct cost by adding the cost of crashing to the normal cost, and since the critical path duration is reduced, so other path also become critical. Okay, so project duration can be reduced by simultaneously crashing activities in the parallel critical path, and then we will, by crashing as per the step 4 and 5, a point is reached when either no crashing is possible or crashing does not result in the reduction of the project duration. So it means for the crashing process, we have to find out the cost slope, and we will arrange the activities as per their cost slope. First crashing of will be done for that activity for which the cost slope will be minimum. Okay, and after that we will repeat this process until the reduction in the project duration is means when the reduction in project duration will be there. So we will repeat this step. Now we come to the one problem of CPM. So here the problem is, draw the network diagram for a small project with activities A, B, C, D, E, F. So these are the number of activities which are involved in our project. The activity predecessor, relationship and the activity duration are as follows. So this table is given in which the activity are given, different activities are given, and immediate predecessor is also given, and activity duration for each activity is given, and we have to find out the critical path with the project duration. So for our reference, I have taken the table here, and we can see here the activities are given, immediate predecessor is given, and activity duration is given. So first we have to draw the network diagram. So how we will draw? We will see the first one is the activity 1. So we can take the help of notes here. We can show it activity A. Now we will write down the duration with the activity. So we can see here the duration for activity A is 1. Okay. After that, we can see for activity B and C, the immediate predecessor is A. It means it will be like this. So we can write down B activity here, we can write down C activity here, and the time duration for B and C are 5 and 6. So we will write here 5, we will write here 6. Okay. After that, we can see here the immediate predecessor of D and E are B and C. Okay. So this is activity D and this is activity E, and the time frame for this D is 2 and for activity E is 3. And then we can see for activity F, the predecessor are D and E. It means if it is 5, then this will be activity F and the duration is this one, and it will be like this. So this will become our network diagram. So now what we will do, okay, now what we will do, we will find out the EFT or the LFT. EFT is EFT is basically earliest finish time and LFT is basically latest finish time. Okay. Now what I will do, and this earliest is the forward movement and this LFT is the backward movement. So first we have to find out for the activity A. So it is the starting point. Now what is the formula that we are going for to use for the EFT is it will be the largest EFT for predecessor plus activity duration. And what formula for we will use for this? LFT for successor activity minus activity duration. Okay, there are some points we have to remember here. For EFT, if there are two predecessor for an activity, we will take the largest value, and if there are two successor for LFT, we will take the smallest value. Okay, now we will calculate the EFT or LFT for this one network diagram. So for activity A, because it is the starting activity or starting event, we will write like this, and it will have the EFT as the because there is no EFT for the predecessor, there is no predecessor for the activity 1 and there is no activity duration. So, it will become 0 here. Okay. And for activity B, what will it become? It will become 0 plus 1. So, it will become 0 plus 1 is 1 here. 1 plus 5, it will become 6 here. Okay. So, in the similarly, it is 2 for the activity 2, it will for activity C, what will it become? It will become 2, sorry, is 6 here and it will become 7 here. 6 plus 1 is 7 here. Okay. And then it will become 6 plus 2, 8, but here 7 plus 3, 10. So, we will write down the largest value here, and for this F activity 10 plus 2 means 10 plus activity duration, it will become 12 here. Okay. Now, we will calculate the LFT. LFT is the backward movement. So, we will start from here. So, because the activity F is the last activity, there is no activity after that in this particular network diagram. So, LFT or EFT will become same for this one. So, we are for differentiating it, we are showing it with the help of the triangle. Okay. We will take the triangle form. So, it will become 12 here because it is the last activity. Now, what will be the LFT for this one? It is the backward movement, we are doing like this. So, it will become 12. This is the LFT for the successor activity. So, LFT for successor activity minus activity duration means 12 minus 2. It will become 10 here. Okay. Now, for this activity, it will become 10 minus 3 means it will be 7 here. For this activity, it will become 10 minus 2. So, it will become 8 here. Okay. Now, here we can see 7 minus 6, it should be 1, and here we are getting 6 minus 5, 1. So, it will become 1 here, and 1 minus 1, it will become 0 here. So, we have calculated the EFT or LFT here. Now, we will calculate the float. Okay, which is the difference between the LFT and EFT minus EFT. So, we can see here for this activity, this difference is 0. So, I am showing is like this. For this activity is 0, for this one it is 0, for this one it is 0, and for this one is 0. So, we can say 1, 2, 4, 5 and 6. This will be our path, or we can say in terms of activity A, C, E, F. This will be the critical path. Okay. And what will be the project duration? Project duration will be the duration taken by these critical activities. So, for A, it is 1 plus 6 plus 3, 7 plus 3, 10 plus 2 means 12 days. So, this will become our project duration. So, in this way, we can calculate the problems of related to CPM. So, that is all from my side on the CPM part. Thank you so much.